Thank you very much for giving me this opportunity. I'm Keiichi Asada at AJA in Taiwan. Today, I would like to introduce a discovery of the shadow of the black hole done by the EHD collaboration. So EHD collaboration is an international collaboration. Primary purpose for this collaboration is to see the shadow of the black hole. More than 300 members in the globe is joining for this collaboration. Of course, from the East Asia, members from the East Asian Observatory, AJA Taiwan, National Astronomical Observatory in Japan, Keiichi in Korea, Shao in Shanghai, and so on. Many members are joining for this collaboration. And today, what I want to tell you is based on this collaboration. So, what is a black hole and what is its shadow? Black hole is a region of the spacetime with extremely large gravity towards the center. So, this is predicted by the theory of the general relativity discovered by Einstein. And because of the huge gravity, no one, even including light, cannot escape from the black hole. So, by definition, we are not able to see the black hole itself. Well, how can we see this? So this panel shows the trajectory of the light traveling across the black hole. And the black hole is here. And then each line corresponds to the trajectory. If light travels very far from the black hole, light just goes straight. But if light travels close to the black hole, its trajectory can start to bend. And this bend becomes larger and larger if the trajectory becomes closer to the black hole, and eventually it terminates in the black hole. So there is some characteristic radius. Within this region, no emission cannot escape from the black hole. So as a result, we are expecting to see the black hole as a shadow in the emitting material surrounding the black hole, and the size of this shadow is expected to be 2.5 times the black hole diameter. However, actually, this size is very, very tiny. For the largest one, the apparent size of the shadow of the black hole is a similar size of the baseball on the moon. So in order to see such tiny things, we need to have a large telescope. Resolution of the telescope is proportional to the observing wavelengths and inversely proportional to the diameter. Now, our observing frequency is 1.3, observing wavelength is 1.3 millimeter, so that in order to achieve such high angular resolution, we need to have the 7,000 kilometer diameter telescope. So this is a comparison. So this is a moon, and this is Earth. In order to have such telescope, we need to have this size of the telescope. Actually, this is impossible. So EHD collaboration are aiming to realize this size of the telescope, this high angular resolution, by forming the virtual telescope. We are trying to link the existing telescope on the globe and virtually try to form such a huge telescope. So this is the EHD elements. One is telescope in the South Pole, Spain, Chile, Mexico, US, and Hawaii. Those telescopes are linked, and we formed the virtual telescope. Its size around 8,000 kilometers. So then, using this telescope, we observed M87. M87 is one of the nearest active galactic nuclei, its distance is 55 million light year from the Earth. So this is a powers of 10 towards the center of the black hole, center of the galaxy. Based on the gas and stellar dynamics, we know this galaxy hosts huge black hole, and its size is around the size of the baseball. In order to see the black hole on this object, DHT made observation in 2017 using the 8 telescope at 6 different locations on the globe. Observation was conducted in 2017, April 5th, 6th, 10th, and 11th. Among those telescopes, ALMA, JCMT, and SMA are partly our telescope. After the observation, very careful data reduction, data analysis, more than 1 year, then we start to reconstruct the image of the black hole. So here is the image. So as you can see, we see like a ring-like or crescent-like structure with a central depression. So this image poses two important things. One is a ring-like structure, and the other is a asymmetry of the brightness. Then, actually, we measure the size of the ring, and it corresponds to the 42 micro-arcsecond. And this is perfectly matched to the expectation by the size of the black hole. And as a comparison, the size of this ring is 700 AU, and it is much larger than the orbit of the Pluto. DHT collaboration made 4 epoch observations, and we see the persistent structure 4 epoch observation. If this is something related to some astrophysical phenomena, we should expect to see some differences. But this common feature is persistent for 7 days or 4 epoch observations. So we conclude this should be the image of the shadow of the black hole, which for human being, the first time we saw this. So the academic impact for this one is very large. So this embeds the existence of the black hole at the center of the galactic nuclei. Also, this is a new tool to explore the gravity, its most extreme limits. And this is pioneer a new era of the black hole physics and astrophysics. DHT collaboration is still working for the image of our galactic center, and the new observation is coming, so stay tuned. And if you are interested in the progress for our collaborations, please visit the webpage or Twitter or Facebook. Thank you very much.